Hello students! In the previous videos, we learned about the combustion reaction of hydrocarbon compounds. Today, let us learn about a new type of chemical reaction, the oxidation reaction of hydrocarbon compounds. We already know what oxidation is, isn't it? Yes. We have studied in the first chapter that whenever oxygen is added or only hydrogen is removed from the compound during the reaction, it is called oxidation reaction. Thus, in the reaction of oxidation of carbon compounds, either oxygen molecules are added or hydrogen atoms are removed. However, we are bothered here only about the addition of oxygen atoms first. But wait, can you recall that even during the combustion of carbon compounds, they reacted with oxygen atoms? So what is the difference between both combustion and oxidation reactions? Let us know. The combustion reaction is a rapid and spontaneous reaction during which complete oxidation of the compound takes place and carbon dioxide gas along with heat, light or water is produced. While oxidation reaction is a kind of controlled combustion reaction carried out under favorable physical conditions with specific reagents to get specific products. Here, carbon dioxide may or may not be produced. In most of the cases, we will see that specific products are produced and not carbon dioxide. Here, by controlled combustion, we mean that they can be easily oxidized in presence of a specific chemical compound or catalysts. So students, in nutshell, we can say that combustion is burning of a substance to produce heat or light, H2O, that is water, and carbon dioxide. It involves reaction with oxygen present in air around it, while oxidation is controlled reaction which may or may not involve burning. That is, production of heat or light is not compulsory. We can remember it like this. Oxidation reaction with heat or light produced is combustion or burning, while if heat or light is not produced, it is simply a chemical reaction. So what kind of special compounds are we talking about? We already said that oxidation reaction is the addition of oxygen atoms to the compounds. Now, can we keep any hydrocarbon compound open in the air and will oxygen be added to it automatically? No, absolutely not, isn't it? We require special compounds that carry out these reactions of hydrocarbon compounds with oxygen. In fact, they help the addition of oxygen to these compounds. They are called as oxidizing agents. Thus, to define them, we can say that agents or compounds that help in oxidation of any other compound are called oxidizing agents. Let's understand this through an activity. Take about 3 ml of ethanol, which is colorless, in a test tube and warm it gently in the water bath. Add 5% of solution of alkaline potassium permanganate, that is KMnO4. Observe that it is dark purple in color. Now add this KMnO4 drop by drop to this solution. When added, we see that ethanol removes its purple color. That is, purple color of KMnO4 in this solution turns yellowish brown. Now add some more KMnO4 drop by drop to this solution. Does the color change occur any further? No, isn't it? Yes. But why is this so? We observed that solution initially changed from purple to yellowish brown. But after that, on adding more KMnO4, there is no color change. This is because the colored permanganate ions of potassium permanganate, that is KMnO4, caused the oxidation of ethanol to form ethanoic acid, which was there in the test tube already. But after some time, no more ethanol molecules were available for oxidation, and hence no reaction took place. So the color of the solution remained yellowish brown even after more KMnO4 was added. Thus, in this reaction, we have seen that in presence of KMnO4, the alcohol compound ethanol is converted to ethanoic acid. Observe that ethanol has two carbons. Let's look at its reaction. Here oxygen is released from KMnO4 and it gets attached to one carbon of ethanol to form ethanoic acid. Observe that ethanol has one oxygen and ethanoic acid has two. Thus, this is the addition of oxygen, that is oxidation reaction. Also, we can say that oxygen is removed from potassium permanganate, isn't it? Yes. And it helps in the oxidation of ethanol. This is why we say that there are special compounds that are required in addition of oxygen to the parent compound to form new compound. And these reagents are called as oxidizing agents. In such reactions, the product formed depends on two factors. One, the choice of hydrocarbon, and second, the choice of an oxidizing agent. There is a wide selection of oxidizing agent available for us in the organic chemistry, each with its own particular properties and uses. There are many oxidizing agents like potassium permanganate, we just saw, chromium trioxide CrO3, chromic acid H2CrO4, potassium dichromate K2Cr2O7, etc. The other determining factor is the type of hydrocarbon chain that takes part in the reaction. For example, primary alcohol gets easily oxidized to form an aldehyde and can further still be oxidized to form carboxylic acids too. Secondary alcohols get easily oxidized to ketone, but further oxidation is not possible. Tertiary alcohol doesn't undergo any oxidation reaction at all. So if you observe these reactions carefully, you will see that one functional group gets converted to other functional groups using different oxidizing agents. Then are we trying to say that oxidation reactions are used to convert hydrocarbons? Yes, absolutely. Changing the functional groups gives us newer compounds that can have a variety of applications. Like the ethanoic acid, a member of carboxylic group, which we get from oxidation of ethanol, is nothing but acetic acid. And we already know that low concentrations of acetic acid is vinegar, which has wide range of daily uses. The propionic acid that we obtained by oxidation of propanol is widely used in food industry as flavoring agent. It is also used in industries as a chemical intermediate in the manufacture of bleaching agents, inks, plastics, cosmetics, perfumes, textile dyes, rubber products, herbicides, and pharmaceuticals, etc. Another compound, propanone, a member of ketone family commonly known as acetone, is widely used as a solvent in laboratories and industries. It is used in preparation of many compounds such as chloroform, sulfonal, a hypnotic drug, an artificial scent, cordite, which is a smokeless powder, many household products like cosmetics and natural care products like nail paints, removers, nail paints, etc. Also, it is used as a cleaning agent to remove harsh stains of greases ranging from fabrics to engines of automobiles. So we now know that oxidation reactions help us produce commercially important products. But the question is how? We will see various reactions in detail in our next video.